Detection: how the street talks back. Modern signals do not only count time. They listen for demand. A fixed time signal changes on schedule whether anyone is waiting or not. That can be acceptable in a predictable downtown grid, but many intersections are not that uniform. A side street may be empty for minutes. A left turn lane may fill suddenly. A pedestrian may press a button late in the cycle. Detection gives the intersection a way to sense demand and adjust service instead of blindly rotating through unused phases. One classic detector is the inductive loop cut into pavement. A wire loop creates an electromagnetic field, and a vehicle changes the field when it stops over the loop. To a driver, it is just a rectangle in the asphalt. To the controller, it is a call for service. The loop is rugged and familiar, but it can be damaged by road work, affected by lane position, and less sensitive to some bicycles or motorcycles if the system is not designed and tuned carefully. Other systems use cameras, radar, infrared, magnetometers, or combinations of sensors. Cameras can see cues and classify movement, but they must handle shadows, headlights, weather, dirt, and privacy concerns. Radar can work well in poor visibility and can measure approaching speed. Push buttons give pedestrians a direct way to request a crossing, though a badly placed button or a confusing delay can make people distrust the system and cross without waiting. Detection changes the emotional experience of waiting. If a light knows you are there, waiting feels more rational. If it seems not to know, the red light feels arbitrary. That feeling matters because compliance depends partly on trust. People are more likely to obey a system that appears responsive and fair. A detector is therefore not only a technical input. It is part of the relationship between the city and the person at the corner. The challenge is false information. A detector can miss a bicycle, think a shadow is a vehicle, stay stuck on after a truck leaves, or be blocked during construction. The controller must treat sensor data carefully, and the timing plan must have limits. Demand-responsive systems are powerful, but they need guardrails. The street can talk back, but like any noisy signal, it can mumble.